guys, so what I normally do is we play this game called the Matrix game. And it's like our big review. And then you would go home tonight and work on your review sheet, which you can still do, except our test is not tomorrow because we have that Google Meet. So I'll be at the meet. If you run into a question, I would encourage you to knock your review sheet out tonight, or at least look at it. And if you are looking at it and you're like, I can do that, ooh, what the heck is that? Or, oh my gosh, binomial expansion, I forgot all of that. Then come with good questions tomorrow. And then if you have a question during the meet, just hang around like we always do and just ask me, and I'll present it up there and show you what you're doing or what you need to do. All right? So normally play a game. It's pretty fun. It has nothing to do with the actual matrix. And it has all these rules that are really confusing that kind of add to the funniness of it. But I'm going to skip all that for you and just give you a chance to go through some of these. Okay? So I have the problem, and I also have the solution on it. I would encourage you to just get out a clean sheet of paper, and we're going to go through as many of these as we can. And I'm going to give you, I normally would not give you a time limit, because normally the first person who gets it right gets the first set of points, and then the next person that gets it right gets the second point. And normally I have you in teams, and only one team member is competing against the other team members. But since we can't share markers unless I throw them in the garbage, or share marker boards, unless I throw them in the garbage, the boards I have, unless I throw those in the garbage or sanitize them, kind of takes it off the table. So anyway, I'm going to run through all kinds of little problems. This is in no way your actual review, but it does give you, from easy to hard, some ideas about what would be on there. All right? So I'm going to kind of, in my head, have a rolling clock, and when I think it's plenty of time, and if you get finished with it and you're done, just raise your hand so I know, or give me a I got it, or whatever. So, problem number 1, go. Shrink this down a little bit. All right. So I'll probably, when I see the majority of you have your hands up, I'm going to throw that thing up on the screen so we can make sure we can get all through all of them. So yes, on this particular one, you evaluate the determinant, you end up with -6. If you miss that for any reason, remember it's that times that minus this product. So the minus the negative gives you a positive, and then you add that to the -20. All right, second problem would be, if you keep a running record of these, it might be helpful too. You have them as extra review problems. So evaluate. And like on your test, you won't have to, you can pick whichever method you want to use. I'm seeing about half, so let me just throw out the key. You can see at least the very minimum if you were on the right path. Now, I could have used expansion by minors or the diagonal method. I chose to use, I don't even remember. Let's see, expansion by minors. So I chose to go 2 times that minor, change the sign of that, times its minor, right there, and then plus that times that minor. And once I got them all filled in, or even if I didn't fill in, I might have been able to do the minor on my own. If I see that minor, I might be able to go 2 times 4 minus 10. And then change the sign of 3 times 0 plus 5. So whatever you ended up with should have ended up being a 7. Yes?
For expansion by minor, it can be any row or any column. Right?
Any row or any column. And I usually default to the top row because I know it's always plus minus plus. But if I see some zeros in there that might help me out, then I might pick something else. But if you do, remember, it's not always plus minus plus when you go to changing those cofactor signs. If you pick that second row, it's going to be minus plus minus. So be careful about that. But if you just want to get in the habit of something, Top row always alternates plus, minus, plus, minus, plus. All right, determine the simplified inverse of matrix A. And what do you mean? What do you think I mean by simplified?
1 over.
That 1 over out front needs to be what? Multiplied in. So when you're doing that inverse, don't leave that fraction on the outside. The only time I would do that is if I was going to use it to solve an equation or something. All right, so right here, the rules are what? Switch, negate, and 1 over the determinant of that. So I'm going to switch them, switch the -7 and the -2, negate the 5 and the 2, and then the determinant would be 14 minus 10 is 4, put that on the bottom, and then of course to simplify I'm going to multiply the 1/4 in. So I get some ugly fractions there. And again, if I was using this to solve an equation, I probably would wait till the end to deal with that 1/4. But if I just want the inverse, I got to do this. All right? All right, on your mark. That's what I would normally say. We're not really in a race, I guess, today. Here. One more. All right, let's see, about half. What happens here? Yeah, it ends up not existing because as soon as you go to the fraction, you get 1 over 0. That can't exist, which means the inverse can't exist. Which means I'd probably do the 1 over 0 part first, just to keep yourself from wasting all the time on the other part, you know? Just to see if it's going to exist. Anyway, so if that happens, DNE, which just means the inverse does not exist. All right, moving on to that next one. It says, multiply the two matrices together, then add the elements in the result. Now, right now, I'm really just concerned with you multiplying them together. I did that so that it would be easy for me to read their answer when we were playing this game. So you don't have to add them together, but just multiply the numbers, the two matrices together. Does everybody know what size determinant we have in the end? 2 by 2, right? That's probably what you should know before you even get started. We talked about a trick to even know if you can multiply. Remember? 2 rows, 3 columns, 3 rows, 2 columns. So these have to be equal to even be able to multiply, but I end up with the 2 by 2. And then we normally circle the rows of this and the columns of that to kind of line up the pairings. So let's take a look at that. I'm going to be circling these 2 rows and these 2 columns. So I wrote out a lot of work here, but I would be going -2, -4, 12. And in my head I'd be thinking -2, -4 and 12 is 6, and I'm putting a 6 right there. If you need to write it out like that to kind of visualize it, that's great too. Right here, next row column, 6, -5, nothing. 6, -5, nothing gives me a 1. Putting a 1 right there. And then when I have to go to the second row, -5, 12, 3, I add that together. And then finally, 15, 15, nothing. I add that together. And you don't have to do that. That was just part of this. If we were playing a game, I was trying to make it to where, like, you would have had your answer on a board and you would have thrown it up here. It's a lot easier for me to see that 47 than it is to be able to see matrices and look at all the individual numbers, because people write sloppy when they're in a hurry and stuff. All right, next one. Okay, it's been a while since we've done these. And this is a little bit different than the majority of the ones I gave you. Most of the time I'm asking for like the fifth term or the middle term or the constant term. But this one, I asked for the term that ended up having an... No, I did ask for the fourth term. There are some where I asked for something different, so just be careful. All right, let's take a look. So what can I always write down? What 3 things can I always write down on these before I even have to actually start looking for what it is I'm looking for? I can put the 10 factorial at the top of the fraction, right? And I can copy these 2 parts down. So start with putting the 10 factorial and then that part and that part down. Now if I'm looking for the 4th term, what do we called it a k value, but the k value would be what? 1 less, so 3. The 3 always goes with the last term. So whatever goes there, that's always 1 less than the place of the term I'm looking for. Put that there. And then what do you know about that and that? They got to add to give me 10, right? So that has to be a 7. And then whatever I put there and there has to go there and there with factorials. And if you have it set up well, great. On your test, you'll at least get half your credit. But this part means something to me as well. So to simplify this, obviously 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, but the 7, 6, 5, 4, 3, 2, 1 would have canceled. So I just put 10, 9, 8 over the 3, 2. Then that's an x to the 35th. That is a negative cubed, so a -8. And normally I would just take the negative and put it out front, because that's where it's going to end up. And then just leave the 8 there. And then y cubed is y to the 9th. And so all I got to do now is cancel whatever will cancel. Multiply the 3, the 4, and the -8 together to get 96. Then times the 10. Don't forget the negative, drop your variables. So what I would normally do is look at the setup. If the setup's good, then I give you, that's worth half. And then if you get the variable part right, that's the other dot's worth. And then if you get this part right, that's the other quarter part. So if you miss that, you get dotted. The numbers, powers are wrong, you get dotted. And if you don't have that setup, you get X, I guess, but that setup's worth half, even if you get this completely wrong. All right, what about this? So this is kind of, if this looks unfamiliar, you don't know where to start. This is kind of like me finding the constant term. Because on the constant term, what were you doing? So you were playing with the powers till all the x's canceled. Well, now what are you doing? You're playing with the powers until what? I get that left over. So instead of having them all cancel, I'm going to play with the powers until A lot cancels, but it cancels leaving me an x to the 8th. So it's very similar to the constant term question, probably more common at a math tournament. But you want to end up with x to the 8th, so give it a shot. Thinking that's about half, maybe. Let's take a look. So what can I always start these problems with? 5 factorial. Yeah, and then copy those two things down. So I'm going to start with that, right? And then I'm not going to know the 3, 2 yet. So literally, I'm going to have this there, and that there. I don't know about the 2, 3. I just want to end up having x to the 8th. So I'm just playing around. I mean, and I know that these two numbers have to add to 5. And look, if I put a 5 and a 0 in there, then I get x to the 20 over no x's. That's not x to the 8th. If I plug a 4 and a 1 in there, I get x to the 16th over x squared. That's an x to the 14th. That's too many 8's. But if I put a 3 and a 2 there, I get 12 x's in the numerator, x to the 4th in the denominator, and that cancels and leaves me x to the 8th. And that was my goal. And that's the same thing I do with a constant term, except I'm wanting everything to cancel with the constant term. And if that's a 3, 2, that's a 3, 2. Bada boom, bada bing. But at this time, what does the 2 do to the negative? Makes it positive, so I don't have a negative answer.
So you just like plug them in until you get it?
I'm guessing and checking. Yeah. There's literally no magic on this. I mean, I guess if there's any magic, I'm thinking, well, if I want to have an x to the 8th right here, I'm going to want more x's on the top and the bottom. So I'm just thinking about that ahead of time. I'm probably not going to start with a 5 there and a 0 there, because that's going to put way more x's on the bottom. So I kind of started from the top, started with higher numbers here. I probably didn't put 5, 0 either. I probably thought maybe 4, 1, and then went to 3, 2. But it truly is just guess, check, revise. All right? All right, what about this? looks like I'm about at half, so let's take a look. So if I'm expanding or evaluating the determinant of the matrix. Now, I didn't have to say the determinant of the matrix and give you a matrix, but I'm trying to expose you to maybe a way Hoover or Vestavia or the state might ask the question. I could have just put a big determinant on either side. But to do that determinant, I have to expand by minors. Diagonals are not an option on a 4x4 or bigger. So what would be the best row or column to probably use? Column 3, because there are so many zeros. Now, column, whatever, 1 would be okay, but it's still going to make you do 2 minors, isn't it? All right, but this would just be a 5 times 1 minor, and that's so much better. And the 5 is in the plus, minus, plus spot. So I'm going to have 5 times its minor. So I'm going to write that out to see it. So the minor of the 5 was the, remember, everything that's not in the row or the column of the 5. So the 0, -1, -1, -1, 1, 3, 0, 3, 8. So I got all that plugged into my minor, and now I just have to expand, or do the diagonal method. But if I expand this minor, what would be a good row or column to pick?
Column 1, maybe.
Column 1, you could use that if you want. You can use any of them, but I love that, right? So if I do that, I go 5 times. Now, if I use that -1, what spot's it in? Plus, minus, because it acts like a big checkerboard, right? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So I have to change the sign of that -1 to be able to expand about that, and then use its minor. So that gives me a 5 times a 1, and then this is just -8 plus 3 is -5 times that 5, -25. But if you wanted to use the diagonal method at this point, that's fine. The diagonal method's not terrible with all these zeros now, because those zeros are going to show up a bunch of times as you're going through these problems. It's going to leave you very little to do, but whatever. But if you're more comfortable with that, definitely do it. All right, I'm going to just show you something. A lot of you are going, ooh, sweet column. I'm going to go about column 1, right? What'd you end up finding? What's your value in this?
0.
0? Is there another way you could have done this?
Combine the 2.
Yeah, look at that first and third column. What did we say? If any 2 columns or any 2 rows were opposites or the same, or even a scalar multiple, which means, like, even if this was like 4, -2, 2, 6, like if you'd multiply by 2, that and that are opposites, all right? So if you see that, then you know this is equal to 0. I tell you, I'd give it a look. I know it's glaring, but I mean, that you're like, oh, he must have meant me to use that column. I know. But even if you do, and you go 3 times that minor, what do you notice about this minor? Opposite row columns, right? So hopefully you saw that and didn't spend too much time, but if you didn't, you were able to get there, I think, eventually. All right, what about, that was the key. What about this? Alright, let's take a look at this one. So I've got this determinant on the left, right? But it's equal to something. So what I think I'll do is just evaluate that determinant, and that'll give me some expression, and then I can just set that equal to 9. So if I evaluate this, it's that times a -6 minus that times that. And I'm just going to distribute all that junk out and be really careful with my signs, making sure I distribute that -5 in, all that kind of stuff. Make sure I distribute that -6 in, and then clean it all up and get to that. Expect if you see something like that on a test, it probably won't be a pretty number like -2. It'll probably be an uglier fraction, because I normally just make these up and just let it ride, because you don't really have to deal with the fraction until the very last second. So they usually aren't that pretty. I think that was just kind of a coincidence. All right, what about this? This is kind of one you either know the rule or you don't, right? So how do you, if I'm looking for a point of intersection, I'm looking for the x and the y. So how do I find the x if I had this information from yesterday's Kramer's rule? Now, if you didn't watch that video yet, you can get on it, but how would I do that?
Divide x by d and divide the dy by d.
So divide the dx by d, so 24 over 2, over 12 would be 2. And then you take the dy over d to find the y value, which gives you a half. Right? And that's the place where these two graphs would cross, or the solution to that set of linear equations. All right, what about this? It says set up what you would do to solve for y. But notice it says do not simplify. I will probably do that on a test, because I'm trying to save you from having to evaluate 5 million 3x3 determinants throughout the course of this test. So I'm looking for you to just set it up here and not. Don't do more than I ask on your test on Thursday, Friday.
I can just like set up the determinants.
Yes.
Okay.
Yeah. All right, let's take a look. So for y, I got to put the what on top? The dy, and the dy is where you take 739 and put it where?
In the middle.
In the middle, and to replace those coefficients. So 214, 739, 455 should be on the top. And then on the bottom, you just have the coefficient determinant, right? Except don't forget to put a 0 in there. And on a test, if it says do that and don't set it up, leave it. You don't even have to say y is dy over d. I'll know you know dy over d if you have these in the right spot. All right, but make sure you get that dy part on in the numerator. Don't get these flip-flops. Go. All right, so 3 times A minus 2 times B. I'm basically asking you to triple that matrix, multiply that matrix by a -2, and then add them together. Or multiply it by a +2. Be careful, every now and then, I'll say 3B minus 2A, and people aren't even paying attention, and they, instead of seeing 3B and tripling that, they still just triple the first one I give them. So be careful and make sure you're actually doing that, what I'm asking. But that would be 3 times the A minus 2 times the B. And unlike a determinant where the 3 just goes into one row or one column, this goes into everything because it's a matrix. And I think it's wise to plug the -2 in and then just change that to a plus. Then it makes it easier because you can just add. As opposed to seeing stuff like -3 minus a -7 and you're like, whoa, so many negatives. It just promotes more careless errors. But now that the negative's already in there, I can go 7, 18, -13, 2, 11, -8. Just becomes a little bit easier for me to do, a little less thinking. All right, what about this? Now every year I give this problem and people think, oh yeah, that's the inverse problem. That's the one that's so hard. But is it? Do I have to use an inverse here to move a positive matrix to the other side? No, I can subtract that. It's only when I'm multiplying by the x that I can't divide it away that I have to use the inverse. So be careful that you recognize that. All right, let's take a look. So again, to solve for x, I've got to get rid of the half and this thing. So I'm going to go ahead and multiply the 2 in, because that's one less thing I have to stare at, and that gives me this row. And then I'm going to subtract that from both sides, and it's going to place it over here and cancel it there. All right, now if you want, you can multiply that negative in and change it to a plus, but at this point I thought I'd save a step. That's like a game, I'm trying to go quickly. So I just went ahead and subtracted that, which is minus negatives adding, and I did that, and then here I multiplied both sides by a 2 to cancel that. So I didn't need an inverse on this problem. All right. Now I'm skipping this next one because in the interest of time, I really want to expose you to some different kinds of problems. So look at not this one, but this one. And you don't have to do the sum of the elements. So I'm just asking you to solve for x. Solve for x. right, so let's just take a look at this and see if you're getting to the right place. So here, unlike that problem we did earlier, I'm not adding something to x that I can subtract to the other side. I'm multiplying it. And what I would really love to do is divide, but since there's not division with the matrix, there is multiplying by its inverse. Now remember, the commutative property didn't work with this. So if I put that inverse there, which is where I want it to get rid of this, where do I have to put it on the right side of this equation? In front of it there. If I put the inverse here and here like I normally would on an equation, I'm going to get the wrong value. So it has to go here next to this, and then here next to that. All right, and how do you find that inverse again? Switch, negate, 1 over, right? So I'm going to keep the stuff in the red was the original problem, right? And then I switched, negated, and then 12 minus a negative 2 is 12 plus 2, 1 over 14. And that inverse went on the left of the left side and on the left of the right side. Now what do I know is going to happen over here if I do this correctly? All of this always ends up giving me what? The identity. Now I kind of skipped a step, because if I multiplied this out, I'm really going to get 14, 0, 0, 14, and then the 1/14th when I multiply it is what gives me the identity. But if you're really careful and you know you're correct, I mean, if you know you are on your math, then this is always going to give you the identity, and the identity times x gives me x. And theoretically, you don't even have to write anything on this side, except x equals. But you do have to remember to put the inverse over here and multiply that out, and then 1/14th into all that. And I try to give you nicer, neater answers on stuff like this on a test to give you some level of confidence that you did it right. But no promises. But I mean, I do try to make them a little bit better so that it's not like, I know this isn't right, that kind of response when you're looking at your answers. All right, and you didn't have to add this together. All right, what about, I forget that stuff. What if you saw that out of curiosity, just comments? What is this telling you to do? Do y'all know how to find the inverse of A on a 3 by 3? No. So are we going to assume the position?
No.
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 That's right. So what do we do? What do we know about A and A inverse? Why do I do it?
So you can divide.
And what do I get when I multiply by an
0.
inverse?
0, no, it'd be 1.
The identity.
0, 1.
So I know that. I can get this without assuming, I know that an inverse times its matrix, A inverse times A, is going to give me the identity. And that part actually does have a commutative relationship. A times A inverse, or A inverse times A, that will give you the identity every time, because they're inverses of each other. So that's a rare condition there, but make sure you know that. Even though I can't find that, I don't care. I know that this is true. Now the one way it's not true, and this is dirty, Vestavia has done this before. They give this question and go, what's A times A inverse? And it ends up being D and E. And I don't think that's the case here, but I may have outsmarted myself. If the determinant of the inverse, you don't know this, but the inverse of a 3 by 3 also has a 1 over the determinant out front. What if they took the determinant and it's 1 over 0? Well, then the inverse doesn't exist, does it? Well, then this product wouldn't exist. And they did that once, and everybody was like, oh, sweet, identity. And they wrote the identity down and still missed it. But if I go back and actually evaluate this, 2 times its minor, which would be, I don't think it is, 0 minus 50, plus 3 times its minor, 0, 0, plus 4 times its minor, 10, 0, gives me negative 140. So no, that does not equal 0. So I'd be okay. But that is one thing you'd have to be careful about. I don't anticipate this being really a test question. Never know, it might be. But do be careful about that, because if the identity, if the determinant of the matrix was 0, you'd have to toss it out. Kind of like we did earlier in that problem where I asked you the inverse and the determinant was 0, so you went, oh, there's no inverse. Anyway, food for thought. What about, Back. Can you do it? 3, 4, 5, 6, 7, 8, 9, 10.
2 to 10.
Is
2 to the
so 2 to the 10th, but guys, you got to know your powers.
8.
10, 24, right? This kind of thing, these powers are going to keep showing up. You guys, because I have not been giving you powers quizzes like I normally do, because I just don't see you every day. I used to give, 1 or 2 a week for the first 3 or 4 weeks. Usually my students know 2 to the 10th, 10, 24. They didn't have to think about it. We do want to get better at that and just keep reviewing those. I don't know what, I don't know. I probably should have waited, but that's a great thing to know because now this question is easily found and you don't have to be like 2 times 2 times 2 times 2 and keep doubling or whatever. So 2 to the 10th. Oh, and why is it negative? Sorry. Remember the rules on upwards diagonals? 2 and 3, I wrote them all out right here. Let me zoom in a little bit. Sorry, I didn't even think about that. I would have choked and missed it. 2 and 3 by 3s, negate the diagonal. 4 and 5s, don't. 6 and 7s, negate. 8 and 9s, don't. 10 and 11s, 10 by 10s, 11 by 11s, negate it. So you got to count those up when you see the diagonal going like this and go, oh, I got to negate the 2 to the 10th. All right, how about this guy? What do I know about this? It's an upward diagonal. So I'm definitely multiplying the numbers, and 3 to the 7th is 2187. Got to know those. Those 3s were always tricky for me, kind of getting them down. The 3 to the 7th, and then how do I know whether to negate it or not?
You don't negate it.
If it's coming down to the right, you never negate it. If it's going up to the right, you have to decide.
Oh.
And this is a what? 7 by 7, and we know that a 7 by 7, like a 6 by 6, gets negated. So I got to negate that. I mean, it's 50-50 on your test, but that's half the answer for me. So if your negative's off, you just missed half of that particular problem, even if you happen to multiply correctly. It probably ought to be all of it, but whatever. Evaluate the determinant here. I'm not going to make you do it, but what might be an idea here? So factor out of 10. So maybe factor out some numbers to make your life a little easier. Now, do you have to? No, you know how to do 3 by 3, so don't spend 10 minutes factoring. You would be finished by then. But I usually factor out of a couple rows. I usually don't mind big numbers in one row, and let me show you why. If I take a 10 out, I get 1, -2, 3. And if I take a, say a 12 out of that, I get 2, 1, 2. And look, if I expand now, I'm just going to have 120 times 1 times its minor, 20 minus 80. Change the sign of the 2 times its minor, 40 minus 40. See how one row of big numbers a lot of times isn't that big of a deal? But you can take that all out if you want. And then plus 3 times 80 minus 20. And then all of that gets added together and multiplied by this. So a -60 and a 180 is a 120, and then a 120 times a 120 is what? You know that 12 times 12 probably is 144, so just 144 with a couple zeros. So, but anyway, you don't have to factor, but it just might make your life a little easier, and I hope I did the math right, yes. Here I took all the numbers out, but whatever. What about this? What time we got? Oh, we're out of time. Hey guys, if you have questions, you might want to work on that review sheet tonight, and then come to the meet with some questions. Just kind of scan it. You see something, you're like, oh crap, that looks ugly, or he didn't talk about this, or I don't remember that. Bring those tomorrow, and then remember your test for you guys will be Friday, and Thursday for you at home.
So for us, we'll have a new lesson on Thursday.
Hold on one sec.